Today we're going to be looking at how to calculate time. Now students, it's important that we know how to calculate time because sometime in the near future you'll be traveling to places that are so far away that their time zones are a lot more different than where you live. They could be several hours ahead or several hours behind. A working knowledge of how to calculate time can allow you to prepare yourselves for such eventualities. Take, for example, our athletes whenever they are going to represent our country in some faraway land. Say, for example, all the way in Asia, Japan, for example. Our athletes and their managers would have to have a working knowledge of what the time zone is like in that area simply by knowing where they are located according to the longitude. Now, in working out the time difference, it would allow them to plan when they would travel to such a country in order to reduce the effects of jet lag and any other effects it may have on them, seeing that the time zones are so vast. So you see, there is relevance in this as well. When calculating time, we should keep in mind that time is gained the further east one travels. Therefore, we're going to add when we're calculating time. Time is lost the further west one travels. So we're going to subtract when we're calculating time. But also keep in mind, and this is even very important, that 15 degrees is equal to 1 hour. And 1 degree is equal to 4 minutes. Note I said keep them in mind because as we calculate time, all of these factors are going to come into play, especially the last two. So right then, let us get on with it. Calculate time west of Greenwich. What do we mean by that? Let's just say, for example, it is 7 a.m. at Greenwich. What time will it be at a place located 60 degrees west? Now, Greenwich is the other name that we give to the prime meridian. We also call it the Greenwich meridian. So in this case, we kind of shortened it, but nonetheless, it is the same thing. The Greenwich meridian or the prime meridian is always worth 0 degrees. So because of that, we're just going to simply divide our 60 degrees by 15 degrees because 15 degrees, as we said a while ago, is equal to 1 hour. Hence, we say 60 divided by 15. 60 divided by 15 will give us 4 hours. So now we know that our time difference at a place located 60 degrees west in relation to Greenwich is approximately 4 hours. Here we have our 0 degree line, Greenwich meridian or the prime meridian, and here is our place located at 60 degrees west. So because it's located west, what are we going to do naturally? We are going to subtract. Remember, the further west you go, the more time is lost. Therefore, we are going to subtract when calculating our time west of Greenwich. Therefore, we will say 7 a.m. minus 4 a.m. or should I say 4 hours. This should give us 3 hours. Therefore, our time will be 3 a.m. at the place located at 60 degrees west. Now, here are a few activities you can try out just to get your brain ticking. Okay, so now we're going to try to find the time at a place located 70 degrees west when it is 7 a.m. at Greenwich. As per usual, we're going to divide our 70 by 15 because remember, 15 degrees is equal to 1 hour, which should give us 4.7. Now students, we cannot use the decimal in order to do our working. We have to translate it in another way. Here we have 4.7. 4.7 now becomes 4 hours and 7 degrees. Just like if we get 3.5, it becomes 3.5 and it becomes 3 hours and 5 degrees. If we get 2.8, it is 2 hours and 8 degrees. If we get 6.9, it is 6 hours and 9 degrees. However, in this case where we had divided our 70 by our 15, we get 4.7. Now the 4.7 becomes 4 hours and 7 degrees. We have to do it this way in order to properly work out our time. Therefore, we are now going to take our 4 and subtract it from our 7 a.m., which will give us 3 hours. Remember I told you about how many degrees equal to 4 minutes? Well, it is now coming into play. 1 degree is equal to 4 minutes. Therefore, we are going to multiply our 7 degrees by 4 minutes in order to change it into minutes. Therefore, we will get 28 minutes. Now that we have 28 minutes, we now have to go back 28 minutes earlier than the 3 hours. So, when we go back 28 minutes earlier than 3 hours, we get 32 minutes. Therefore, our time will be 2:32 a.m. Once again, when we subtract our 4 hours from our 7, we get 3 hours, or what we consider to be 3 a.m. After we work out our 7 degrees into minutes by simply multiplying it by 4 minutes, and the reason why we multiply it by 4 minutes is that 4 minutes is equal to 1 degree. Therefore, when we multiply our 7 degrees by 4 minutes, we get 28 minutes. So now, having our time being 3 a.m., to get the accurate time, we will now have to subtract 28 minutes from our 3 a.m. or our 3 hours. In other words, in class, we will go back 28 minutes earlier than 3 a.m. and this will give us 2:32 a.m. as our time. Let's look at this other one. What time will it be at a place located at 15 degrees west if it is 8 a.m. at a place located at 75 degrees west? Well, as you can see, we have two different places now. We don't have Greenwich. We have two other places besides Greenwich and another place. We have one place located at 15 degrees west and another place located at 75 degrees west. This is what we're going to do. We are going to simply subtract our the place located at 15 degrees west from 75 degrees west. Therefore, it will be 75 minus 15 all over 15 degrees. Once again, we use 15 degrees to divide whatever the working out is going to be, because 15 degrees is equal to 1 hour. Therefore, we get 60 when we subtract 15 from 75 all over 15 degrees, which will give us 4 hours. Let's see what we're working with here, because it might look like a straightforward slam dunk, right? Okay, let's see what's going on. Let's go back to our chart. Here's our place located at 15 degrees west. Here's our place located at 75 degrees west. Now, we want to find the time of a place located at 15 degrees west. So therefore, what direction is 15 degrees west from 75 degrees west? What direction is our arrow pointing? East. Therefore, the place located at 15 degrees west is actually east of the place located at 75 degrees west. Now, what are we supposed to do if we're looking for the time of a place located east in relation to the other place? Do we add or do we subtract? Well, students, we add our 4 hours to our 8 a.m. because 15 degrees west is east of 75 degrees west, despite being located generally west of 0 degrees longitude, which is Greenwich Order Prime Meridian. Remember, we add when we're going east. So because 15 degrees west is located east of 70 degrees west, or should I say 75 degrees west, we are going to simply add our 4 hours to the 8 a.m. because when you're going east, you're gaining time. So therefore, you must add. So we say 4 hours plus 8 is equal to 12 noon. So our answer should be 12 noon or 12 p.m. That is our answer. Okay, let's try it this way. What time will it be at a place located at 75 degrees west if it is 4 a.m. at a place located at 15 degrees west? This time, we want to know the time of a place located 75 degrees west, since we already know the time at a place located at 15 degrees west. Once again, we're going to subtract our 15 from our 75, and the product or the difference is going to be divided by 15 because 15 is equal to 1 hour. This means 60 divided by 15 is equal to 4 hours. Now, because the place located 75 degrees west is located west of 15 degrees, we are going to do what? What are we going to do? Are we going to add or are we going to subtract? What do you do with time when you're going west? Remember, we lose time when we're going west, so therefore do we add or do we subtract? If you say subtract, you are indeed correct. We will subtract our 4 hours from the time that we have, which is 4 a.m. So we simply say 4 hours, or should I say 4 a.m. minus our 4 hours. Either way is the same thing. Therefore, our answer will be 12 a.m. And that is how we work out our answer. Now remember, students, even though both places are west of Greenwich, remember, you're looking for the time of a place in relation to the other. So if you're looking for the time of a place that is located west in relation to the other place, even though they're all west of Greenwich, remember, you're going west, so you still have to subtract. But if you're looking for the time of a place located east in relation to the other place, even though they're both west of Greenwich, remember the principle. If you are going east, you are gaining time. So therefore, you have to add. That is the reason why we add if we're looking for the time of a place that is located east in relation to the other place. Here are some activities you can also try on your own just to get your brain ticking. Now let us calculate time of a place located east of Greenwich. Now students, it's the same principle as with the time calculating going west of Greenwich. The only difference is we're going to be east of Greenwich this time around. So if it is 12 noon at Greenwich, what time will it be at a place located at 45 degrees east? Simply divide 45 by 15, and this is going to give us 3 hours. Remember, 15 degrees is equal to 1 hour. So here is our place located at 45 degrees. And as you can see, 45 degrees is east of 15 degrees, or should I say east of Greenwich. Therefore, do we add or do we subtract? We're going east. So going east means that we're going to gain time. And if we're gaining time, it means we're going to have to add to the time that we have. Therefore, it will be 12 plus 3, which will be equal to 3 p.m. And that is our time, east of Greenwich, at a place located 45 degrees east. If it is 12 noon at Greenwich, what time will it be at a place located at 76 degrees east? Okay. So we want to know the time at a place located 76 degrees east of Greenwich when it's already noon at Greenwich. Again, we're going to divide our 76 by 15, which should give us 5.1. Once again, we're going to translate our decimal into hours and degrees. Therefore, it will be 5 hours and 1 degree. This means we're going to add our 5 hours to our 12 noon or our 12 p.m., which will give us approximately 5 hours. Now, since we need to translate or turn our 1 degree into minutes, we will now multiply 1 degree by 4 minutes, since in principle 1 degree is equal to 4 minutes. This gives us approximately 4 minutes. 4 times 1 equals 4. So we get 4 minutes, right? Okay. So since we have 5 hours and we're going east, all we're going to do with our minutes is to add it to our 5 hours. So we add our 4 minutes to our 5 hours, and this will give us 5:04 p.m. And that is the time of the place located 76 degrees east of Greenwich. It's a lot easier when you're going east. All you do, you add. Alright students, so now we are going to try to find the time of a place located at 75 degrees east when it is already 3 p.m. at a place located at 45 degrees east. To do this, we will simply subtract our 45 degrees east from our 75 degrees east and divide them both by 15. So we say 75 minus 45 over 15. 15 being that 15 degrees is equal to 1 hour. So 75 minus 45 equals 30 divided by 15, which is equal to 2 hours. Now let's go back to our chart to see what direction is 75 degrees east in relation to a place located at 45 degrees east. So here's our place at 45 degrees east, and here is our place located at 75 degrees east. Now if we look at the arrow is pointing in what direction? If you say east, you are correct. The arrow is pointing in an easterly direction, which means that the place located at 75 degrees east is located east of the place located at 45 degrees east. So since we're looking for the time of the place located at 75 degrees east, which is located east of 45 degrees east, it means that we are actually gaining time. And if we're gaining time, it means therefore we'll have to add to the time that we already have at 45 degrees east in order to find out what time it will be in order to attain the correct time at 75 degrees east. Therefore, we say the time that we already have is 3 p.m. So we're now going to add the 2 hours that we've already calculated, which is the time difference between the place located at 45 degrees east and 75 degrees east. So we're now going to add our 2 hours to the 3. This means 3 plus 2 equals 5. So it means therefore that the time at a place located at 75 degrees east is approximately 5 p.m. Now remember earlier we calculated that there is a 2-hour time difference between the places located at 45 degrees east and 75 degrees east. Well, let's put that to the test a little, shall we? So we go back to our chart. Here is our 45 degrees east, and we say 1 hour, then we say 2 hours. That landed right on the 75 degrees east line. So it proves therefore that the theory is correct. Our calculations were indeed right. We actually have a 2-hour time difference between the places located at 45 degrees east and 75 degrees east. Okay, so let us now calculate the time of a place located at 45 degrees east if it is already 10 a.m. at a place located at 75 degrees east. Once again, we're going to subtract our 45 degrees east from our 75 degrees east. So we say 75 minus 45, all divided by 15, which gives us 30 divided by 15, which gives us 2 hours. Now, let us go back to our chart to see what direction is the place located at 45 degrees east in relation to the place at 75 degrees east. So here we have our 45 degrees east, and as the arrow indicates, pointing to the line which is at 45 degrees east, it means therefore that 45 degrees east is actually east, or should I say west, of 75 degrees east. So if 45 degrees east is located west of 75 degrees east, are we losing time or are we gaining time? Well, if it is west, as the arrow indicates, it means therefore we are losing time. So what do we do if we're losing time? If we're losing time, it is prudent for us to minus or subtract our 2 hours from our time that we already have. So this means that 45 degrees east is located west of 75 degrees east. There's our place at 45 degrees east. Let's get back to the drawing board. So the time that we have is 10 a.m. and we already worked out that there is a 2-hour time difference between the places located at 75 degrees east and 45 degrees east. So if 45 degrees east, which is the place we want to know the time for, is located west in relation to a place located at 75 degrees east, it means therefore we are losing time. So we have to subtract. Hence, we say 10 a.m. minus 2 hours, which will give us approximately 8 p.m. No, not 8 p.m. If I have p.m. there, it's a typographical error. It actually is 8 a.m. All right, so just disregard the p.m. and say 8 a.m. All right, so we have 8 a.m. So our time is approximately 8 a.m. since 45 degrees east is located west of 75 degrees east. Therefore, we have to subtract in order to gain the time, in order to get the time that we're looking for. So even though both places are located east of Greenwich, you must keep in mind that since one of these places is located west in relation to the other, we have to subtract. We are seeking the time for a place located at 45 degrees east, and 45 degrees east is actually west of 75 degrees east. So because it is west of 75 degrees east, we are going to subtract our 2 hours in order to get the correct time. So it means therefore that the place located at 45 degrees east is 2 hours behind a place located at 75 degrees east. Therefore, our time is 8 a.m. All right. So now let us see if our chart proves us right. So we have 1 hour right here, 2 hours, exactly on the 45-degree line. So it shows that there's approximately a 2-hour time difference between the places located at 75 degrees and 45 degrees east. All right, students. So here are some coordinates that you can use and calculate the times for. This will give you a bit of an exercise, so feel free and do them at your leisure. Here is some more, or here are some more, my grammar. All right. Now, the last thing we're going to learn to do is to calculate time from west to east of Greenwich. Okay, so now we're going to calculate the time of a place located at 60 degrees west when it is already 6 p.m. at a place located at 45 degrees east. Wait a minute. This is not kind of like what we were doing earlier. Remember, what we were doing earlier, we were actually calculating the time of places which are both located either west or east of Greenwich. But in this instance, we have one place that is west of Greenwich and one place that is east of Greenwich. And we want to know the time of the place located west of Greenwich in relation to the place that is already at 45 degrees east of Greenwich. So we know that it is already 6 p.m. at the place located at 45 degrees east of Greenwich. But we want to know what time it is at a place located at 60 degrees west of Greenwich. What are we really dealing with here? Let's get to our chart for a second. Now, here's a place located at 45 degrees east of Greenwich. Here's a place located at 60 degrees west of Greenwich. Both places are on different sides of the Greenwich meridian. We know it is already 6 p.m. at the place located at 45 degrees east of Greenwich, but we want to know what time it is at 45 degrees west of Greenwich. As you can see, the arrow shows that we are going in what direction? A westerly direction, because 60 degrees west obviously is west of 45 degrees east. Very simple, very straightforward. So let's get back to the calculation. So how are we going to solve this little riddle that we have before us? Well, we're going to first of all add our 45 degrees to our 60 degrees and divide them by 15 degrees. Once again, the magic number 15 still remains. So 45 plus 60 equals 105 divided by 15. This will give us approximately 7 hours. Okay, let's pause for a while. What direction is 60 degrees west of 45 degrees east? Obviously, it is actually west of 45 degrees east, right? As it already implies. So it means, therefore, class, that we're losing time if we're moving in a westerly direction. So if we're losing time, what should we do in this case? Should we add or should we subtract the hours from the time that we already have? Well, if we're going west, we're losing time. Therefore, we subtract. Hence, we say, all right, so there we have our chart showing that 60 degrees west is west of 45 degrees east. Good. So now we do the calculation a little further. So we say 6 p.m., which is the time, is going to subtract our 7 hours. So we say 6 minus 7, which should equal to 11 a.m. Now class, remember, whenever we are subtracting time, what we're actually doing is going back earlier before the previous time that we have. So if we have 6 p.m. at a place located at 45 degrees and our workings show that it is 7 hours time difference between the two places, then what we're supposed to do is to go back 7 hours earlier before 6 p.m. Now going back 7 hours earlier before 6 p.m. should give us a time of 11 a.m. Therefore, our time is approximately 11 a.m. All right. We know that when we worked out our time a while ago, we got a 7-hour time difference. Are we sure? Well, we have our chart here. So let us count our time difference. Once again, we have our 45 degrees east, and we're going to count now. So we say 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours, right on the 60 degrees west mark. So therefore, we are approximately 7 hours behind at 60 degrees west. In other words, then there is a 7-hour degree, or should I say there's a 7-hour time difference between the places located at 60 degrees west and 45 degrees east. Okay, students, let us take it another step further. We want to know what time will it be at a place located at 45 degrees east when it is already 6 p.m. at a place located at 60 degrees west. We're actually reversing the places this time, right? So here are the places at 60 degrees west, 45 degrees east. And we want to know the time of the place located at 45 degrees east. So therefore, according to the arrow, 45 degrees east, obviously, is east of 60 degrees west. So if it is east of 60 degrees west, it means we are gaining time. And if we're gaining time, what should we do? Should we add or should we subtract? If you say add, you are indeed correct. So, just as what we did previously, we will add 45 to the 60 and divide them both by 15. So we have 105 divided by 15, which is equal to 7 hours. Again, we go back to the chart. 60 degrees west, 45 degrees east, and our 45 degrees east, as we said a while ago, is located east of 60 degrees west. So therefore, we are going to add our 7 hours to the 6 p.m. So we end up with a time of 1 a.m. because we have jumped 7 hours ahead of 6 p.m., which is at 60 degrees west. So the time at 45 degrees east is approximately 1 a.m. Let us put that theory to the test. We know that there is a 7-hour time difference, so we're here at the 60, and we're going to go all the way to the 45 degrees east. So we'll say 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours. So it is indeed correct. The calculations were indeed correct. We have a 7-hour time difference between 60 degrees west and 45 degrees east. So before we go, here is a little activity that you can use to exercise your calculating mindset. Anyway, students, this is the end of our calculating time lessons. Thank you very much for joining me. Feel free to rewind as much as possible, and I do hope you learned something and that this video was very beneficial and makes calculating time a whole lot easier for you. Have yourselves a great day and take care.